It's a minute past, so I'm going to get going. We've got a really interesting and exciting hour in front of us. So let me say good evening and welcome to the UCD EGA Spring Panel Discussion. I'm Magella Henshin, the current president of the EGA, and it's given me great pleasure to welcome all our speakers and virtual audience to this discussion of the role of energy security as we transition to a carbon neutral society. As someone who's worked exclusively in the energy industry all my working life, I'm passionately interested in this topic, and I'm sure that all of you will find tonight's presentations and discussion of great interest. I will shortly introduce our panelists, but firstly, I'd like to set the context. A look back at history shows energy access has underpinned many conflicts and wars around the globe. The Russian invasion of Ukraine is the most recent example of this. It impacts on Irish fuel and electricity prices, and the consequent impact on ordinary Irish citizens highlights that secure energy access is intertwined with stability and prosperity. The transition to a zero carbon future is already underway in developed economies around the world. For Ireland, we have had a long history of dependence on imported energy sources, which have made us especially vulnerable to adverse impacts on our energy security arising out of international events. Thus, the development of renewable and energy storage technologies, as well as having great potential to help us in our response to climate change, puts us in a position for the first time in this technological era to envisage a world where we might have real energy independence and security. But how do we get there? How do we overcome the challenges involved in moving to this net zero carbon position? And how do we ensure security of supply during the transition? Our speakers this evening will explore these themes, considering the timelines for development of national energy resources and Ireland's place within the wider European energy system. We're going to start with 4 short presentations and then open the floor to questions. So please use the Q&A button at the bottom of your screen to submit your questions. Now, before handing over to our first speaker, let me introduce all 4 of our panelists. Claire Kwan is the Networks Operations Manager in ESB Network Stack. Her role involves leading the safe and efficient operation of the distribution system on which all domestic and most industrial electricity customers in the Republic of Ireland depend, and to which a large proportion of our renewable generation is connected. The network's operations function includes the 24/7 National Distribution Control Centre, the operational systems for the distribution system, and operational policy for ESB Networks. Claire herself joined ESB Networks in 2000 and has held a variety of engineering and management roles across ESB Networks. She's been a senior manager with the company since 2014, and she's a graduate in electrical engineering from UCC. Our second speaker will be Jonathan Ruddy, who joined Greenlink Interconnector project in September of 2021 as technology manager. Greenlink Interconnector is the company tasked with delivering a subsea and underground electricity interconnector linking the power markets in Ireland and Great Britain, and it's planned for commissioning in 2024. It's one of Europe's most important energy infrastructure projects. Jonathan is responsible for the technical management of the engineering, design and procurement contracts and the interface with EirGrid and National Grid. Prior to joining Greenlink, Jonathan worked at EPRI Europe in the transmission operations and planning team, performing several roles across HVDC, planning and renewable integration. He's advised utilities on the development and integration of new transmission and generation projects. He completed his bachelor's, master's and PhD in electrical engineering in UCD, with the latter focusing on the integration of offshore wind. John Melvin, our third speaker, is the Director of Energy Networks and Legal at the Commission for Regulation of Utilities, the CRU. John gained his BE in mechanical engineering from UCD in 1994, and he worked in a variety of roles in companies in the early years of his career, including working on combined heat and power related activities at both Singleton White and Muskegon Power, before moving to the CRU in 2008, where he became the Director of Energy Networks and the Legal Division in 2016. And our final speaker is Andrew Keane, who's Director of the UCD Energy Institute and Director of the SFI Energy Systems Integration Partnership Programme, which brings together multidisciplines to address research challenges facing the energy sector. In particular, as we accelerate the decarbonisation of our energy system, this is a particularly important area of research. His other research interests include the impact of new energy resources on the power system, from the residential network right up to high voltage transmission systems. And he's also focusing on the impact and opportunities presented by renewable and distribution energy resources on the electrical networks. Previously, Andrew has served as Head of School of Electrical Engineering, Electrical and Electronic Engineering at UCD. He's held positions with ESB Networks in Dublin and with Smarter Grid Solutions in Glasgow. In 2015, he co-founded Novo Grid, a grid automation company developing software solutions for renewable generators and utilities. Andrew got his BE and PhD in UCD. So as you can see, we have 4 speakers with great credentials in this area. And right now, I'm going to hand over to Claire to give the first of the presentations. Thank you.
You're still on mute there, Claire. Just
sorry about that. No, I think we're good, are we?
loud and clear.
Yeah. Hopefully
we
that's
we can see things perfectly, Claire. Yeah, and we can hear
Great.
you.
Thanks. So sorry about that. A little bit just to get up and running. So as Magella said, I'm the Network Operations Manager, and I'm just going to focus on network operations and the role of ESB networks and the distribution network in particular as we transition to net zero. So obviously, society, we're becoming more and more dependent on electricity as heat and transport is electrified. As we work from anywhere, society is absolutely dependent on secure energy, and the role of ESB networks and the network in general is pivotal in order to connect customers to that secure energy future so that they can transition to net zero. And so I'm going to just talk first this evening a little bit about the overall system. So from a system perspective, how the transmission system and the distribution system, how it all works together, and how we have connected and we continue to connect renewable generation, and also that we support the electrification of load at the moment through a range of projects that are ongoing, be it smart metering and indeed innovation trials that have progressed, and how we are using that information to develop the network over the coming years. I'm going to talk about, so the transition, as we all know, to carbon neutral society is already underway, and ESB networks is driven to ensure and support that we are supporting net zero, and by 2040 we will be at net zero. So we have already connected a significant amount of renewable generation, and as Magella mentioned at the start, quite a proportion, actually more than 50%, is connected to the distribution system, and ensuring that there is resilient network and infrastructure at all voltage levels is absolutely critical over the next number of years, as it has always been. Similarly, as customers wish to go to net zero, empowering our customers, be it by providing information from smart metering, or indeed ensuring that our communities can achieve net zero by, be it in energy communities, that's all part of what we're doing through a range of projects. So I suppose, just to look first of all, this is a little pictorial of the network. And you can see first from a transmission perspective on the right-hand side, generation traditionally has been connected to the transmission system, and then it travels in one direction, or it has traveled in one direction to the load center. So down through the voltages from the transmission to the high voltage distribution, through the medium voltage and the low voltage. And that's how, I suppose, across the years, the network has been developed. And just to give a sense of scale then, on the transmission system at the moment, there's of the order of 7,500 kilometers of transmission network. So that's like the motorways. And then you've got the distribution network. So there's the volume of distribution that network then is very significant. So there's of the order of 170,000 kilometers of overhead line and underground cable from 110 all the way down to low voltage on the distribution network. And how the system then works together, obviously the transmission system and the transmission system operator, EirGrid, manage the transmission network and ensure that they do the balancing with respect to generation and demand from the NCC. And then the distribution network is controlled and managed from the National Distribution Control Centre. And clearly it's critical that both system operators communicate and work together. And we have done that always, and we continue to do that really closely. And that's absolutely critical as we transition to net zero. Just looking then at the volume of renewable that's already connected. So there's of the order of 4,700 megawatts connected at be it on renewable generation connected, be it at transmission or distribution level. And over the last number of years, as we all know, and with EirGrid, Ireland is a leader with respect to operating the system with the amount of renewables that we have. So at the moment, 43% of energy came from renewable sources in 2021. And it's possible to operate the system at 75% SNSP at any given time, based on the projects that have been done over the last number of years by EirGrid, and also working with ESB networks as well. So I suppose that's kind of just a little bit of what the network looks like now. And obviously, as time goes on, and in the next number of years, what's happening is more and more renewables are connecting, and more renewables are going to connect at different voltage levels. So all the way across the voltages. And this is very different to how the network was originally envisaged and developed and operated, because our control and visibility, as one can imagine, there's very significant amounts of control and visibility at the transmission and the distribution high voltage and medium voltage levels. But because of the fact that power flow would have always gone in one direction previously, at the lower voltages, there isn't as much visibility and control. But clearly over the next number of years, that's all changing. As a society, we actually embrace renewables at the lower voltages and in our own domestic dwellings. So that's a big change. And just to give a little bit of kind of insight as to what that might look like. So clearly, when we still have the overarching model. So you've got the transmission system and the distribution system. But now you can see that there'll be renewables connected all across the voltage levels. And similarly, there'll be load growth and demand as we electrify transport and we electrify heat. And what is very important to recognize then is the impact that will have on the power system and on the distribution system as time goes by. So what we need to ensure is that power flow across the network is managed in a way that we can ensure that we have stable and secure power for all of our customers at all times. And we can do that, and that's actually already happening, because with the provision of different projects that are already ongoing, for example, smart metering and the information that's coming from smart metering, and the enhanced operation and visibility that we're putting in place, we will be able to manage the power flow and the demand on the network all across the voltages in order to ensure that we have that secure electricity supply across all the voltages. And I suppose that's kind of one of the biggest changes in the next number of years is on the lower voltages. And we're working with EirGrid and with all industry and with customers to ensure that we're getting the insight that customers have and stakeholders have in order to develop the network and the operation systems that will enable us to manage that. So that's ongoing at the moment. And that visibility then you can see down the voltages to the low voltage is absolutely critical. And that's what we're progressing at the moment. So ensuring that resilience is maintained so that we are both developing the network and also maintaining and connecting new customers, be they generation or demand, and ensuring that customers have a secure knowledge that their power can be relied on is absolutely critical, because we want to empower the customers then and customer communities to achieve net zero themselves. So I suppose that's kind of really just a little a snapshot on how the power system will work together, both from a transmission and across the voltages in the distribution system, and with all the stakeholders and industry to ensure that that happens. And I suppose that's kind of the summary of my presentation. It's also important to recognize and just to say that in the event that there is a power system emergency, or like as we have always had, we have protocols and procedures in place as the DSO, working with EirGrid on the TSO side to ensure that the necessary action will be taken to secure the power system in the event that there was an emergency or an issue, as we've always had. That's kind of just that's the end of my, so I'll just stop sharing there now.
Thank you very much, Claire. And having set that scene there, I think it might be a very good time to move on to Jonathan, who's going to talk to us about the interconnection of everything you've talked about there with other utilities, I believe. So Jonathan, up to you.
Okay, yeah, you can see that okay, John?
Yeah.
Thanks. Jonathan Ruddy, Technology Manager, and thanks, Michelle, for the introduction and for very clearly explaining Greenlink as well. Saved me a job on that one. So let me just pull up my screen here, apologies, 1 second. So yeah, the need for interconnectors as we transition to net zero. So I'm really just going to give a quick overview of the Greenlink project and some of the broader benefits we have, and then I've got a couple of slides at the end that really come back to net zero and interconnectors. So as Majella mentioned, the Greenlink project is a HVDC connection cable from Ireland to Great Britain, so from County Wexford to a place called Pembroke in Wales. And its main purpose is connecting the two grids to transfer 504 megawatts of electricity in both directions. So at any one time, you can transfer in one direction, either exporting from Ireland to GB or importing from GB to Ireland. So I've got a DC cable, so that requires quite a bit of infrastructure onshore on both sides to convert from AC to DC. On our grid connections are close to two relatively large substations on each side, which makes it quite a convenient location for the interconnector. On the diagram in the bottom here, you can see our offshore cable routes. We've got 160 kilometers of sea cable and around 30 kilometers of onshore land cable, 25 of that on the Irish side and 5 of that on the Welsh side. I guess our high level program and our sort of detailed study started in 2018 in earnest, but really the development started maybe 4 years before that, 2013, 2014. Lots of planning applications and onshore and offshore planning consents granted in 2020 and 2021, and we were fortunate to start construction in January 22, and we will be commissioned fully with takeover of the interconnector by the end of 2024. So a 3-year construction program for the two sites for the interconnector and the offshore and onshore cable routes. And so just to make the point, I guess that's 10 years of development for this project if you include the initial development phase. So our current status, we're really, it looks like any field that's just been dug up at the moment. We're doing quite heavy enabling works. And if you what will be here on this site in Great Island is is a converter station, approximately 180 meters by 100 meters of a footprint. Quite a large station that will convert the DC cable DC into AC to connect to the grid. So I guess Greenlink is really a cost-efficient source of future interconnection for Ireland. And to focus on maybe some of the benefits during construction first, there's going to be a break of jobs during construction, 250 Irish jobs, and a lot of knock-on impact for the local area. We'll also have 20 odd permanent jobs in operations, maintenance, and security and everything else that's required. And it helps to reinforce the electricity grid. So we're increasing security of supply, bringing importing power when it's needed, and exporting power to allow more renewables. So to talk maybe then about the broader benefits of Greenlink and of interconnectors in general. So the Greenlink project has the potential to import or export power for approximately 380,000 homes. It will connect the Irish and GB electricity markets, as I said. It's a strategic asset for both the UK and for Ireland and for the European energy markets. It will help both Ireland and the EU to achieve its energy policy and climate objectives. It will support the growth of renewable energy, particularly wind and solar, and particularly offshore wind. The large offshore wind projects will no doubt make use of the export capability on all the interconnectors that are planned and currently exist on the Irish system, and thus supporting decarbonisation and increasing security of supply for the customers. Yeah, and I've already mentioned the jobs and the value for money, providing downward pressure on electricity bills. So energy security then and net zero. So on the need for interconnectors. So we know that there's legislation drafted for net zero both in Ireland and the UK to get to net zero by 2050. Interestingly, on the UK side, their not legislation, but their white paper supporting the legislation requires their UK interconnector capacity to grow from approximately 5 gigawatts at the moment to 18 gigawatts. And maybe more recent projections have even increased that further to allow a lot of import and export of the significant renewables required. And these strategies both require and depend on, to get to net zero, huge offshore wind build out. They require solar, hydrogen, batteries, interconnectors, among many other technologies. But only interconnectors have sort of proven capability to manage intermittence on a large scale. Batteries and other other systems like that have the capability to store electricity can do so quite usefully. But if you can export, in this case with Greenlink 500 megawatts at any one time, and that helps to manage the intermittence. If you've got quite a windy day, you can export that 500 megawatts, and it could be exported through the UK further afield to the rest of Europe. And likewise, if we've got a day where there's no wind or low wind, we can be using that capability to import and ensure our security of supply. So interconnectors, they're a low risk option. They're a proven technology and are highly utilized when they're available. And as we push to more renewables, there'll be greater intermittence and a greater role for interconnectors. And so one, maybe just a brief example, if you think of like quite a windy day, which we have quite often in Ireland, and the wind is moving across and hits the onshore wind in Kerry and hits the future offshore wind in the Irish Sea, we'll have a lot of potential to export power to the GB, which might not be experiencing those windy conditions yet. But wait until tomorrow when the wind starts to die down in Ireland and that storm front has moved across to Scotland, and they then have that serious amount of wind that they need to export, and we might have a case where we need to import power. So that's that to me is really the huge value of interconnectors for energy security. So I'll stop there. I'm conscious that we want to get to the discussion later on, and I'm happy to take any questions at the time.
Thanks a million, Jonathan. And yes, we do want to keep moving on. So I'm going to call on John Melvin now to give us his presentation. You okay there, John? So we can see your slides, John, but we're not hearing you yet.
Am I now off mute?
Yes, you are. Thank you.
Excellent. It moves the mute button to the screen you're sharing. In any event, so I'll give a short presentation on security of supply and the energy transition, perhaps a slightly different take on it to some of the other presenters. Now, page down, there you go. I had a classier looking version of this sheet, but I couldn't find it putting this together, so you'll have to forgive the rather basic looking screen. You might be a bit disappointed in the way I focus on the transition to 2030, but as opposed to out further. But having lived the experience of the transition to 2020, which took us more than 12 years to reach, if you go down the 2020 column there, to reach a renewables target of 40%, which we reached sometime between 2020 and 2021. But essentially to remember that that many years of work to get us to 40% meant we had 60% non-renewables. Claire has touched upon this earlier. At the time in 2020, the max instantaneous volume we could safely take from renewables in 2020 was 65%. So that meant that at those times, 35%, or at all times, a minimum of 35% of generation, electricity generation, would have come from non-renewables. But on the other hand, remember that, you know, you've heard it so many times, the wind doesn't always blow and the sun doesn't always shine. At times during that period, circa 100% or close to 100% of the power generation, electricity generation, would have come from non-renewables. So we have a target now to aim to reach 80% annual volume from renewable sources by 2030. There's a significant ambition in the Climate Action Plan 21 or 19, that was 70%. In the Climate Action Plan 21, that is, I think, up to 80%. But then in the rest of the plan, it talks about 80% really only. Even then, it's worth noting that that would mean that on average over the year, 20% of the electricity would come from non-renewable resources. In order to achieve this 80% overall, running down the column for 2030, we would need to see the maximum instantaneous volume from renewables, or SNSP, system non-synchronous penetration, of greater than or equal to 95% is the expectation we would need to achieve that. And that would mean that up to 95% of the generation supply and demand would be from non-thermal or non-traditional sources. But even then, what that would mean would be that sometimes the sun wouldn't shine and the wind wouldn't blow. Even then, at some times, we would be 100% or close to 100% reliant on renewables. At the top of this, 2020, what I'll do over the next few slides is 2021 and 2022. But from 2020, certainly in CRU, we had the view that it says my internet connection is unstable. Can you hear me? You can?
Yeah, we can hear you, John.
Thanks, Magella. In 2020, CRU took the view, well, it was clear, I think, that a large volume of the existing generation plant was expected to exit over the forthcoming years due to a number of reasons. Aged plant, the Industrial Emissions Directive, meaning certain plants would be expected to close. The Clean Energy Package, some European legislation would make changes to capacity mechanisms to rule out higher emitting plants from the capacity mechanism. Economic position due to carbon price, and the economic position would be negative for less flexible plant. And also lots of the plants we have on the system were designed really for the fully thermal world, where a combined cycle plant might have been expected to start and stay running for weeks on end, and stopping and starting those machines in a world in order to facilitate intermittent renewables. There is a concern that that reduces the reliability of these plants. So our view was, notwithstanding the targets and the need to move from 40% renewables to a target then of 70% renewables, now of 80% renewables, that the system would still need new dispatchable plant. Other things that were happening, and I think are still happening, certainly were visible in 2020, were increases in demand. So the increase in demand due to electrification of heat and transport is part of the overall transition to net zero by some stage, but the move towards greater reductions from the economy by 2030 and onwards of carbon. So that electrification of heat and transport, the quickest, simplest, perhaps, and easiest way to decarbonize heat and transport. So that will increase, if you have just an electricity hat on, that will increase demand for electricity over the next number of years. General economic growth being experienced at the time. We'll see if there is a reversal of that over the next number of years, but that too would lead to an increase in electricity demand, but also a noticeable and very significant increase in demand due to data center growth, driving a significant element of the increase, or the expected increase, and the increase in electricity demand at that time and since. So just to say, there were generation adequacy concerns predating Russia-Ukraine. So prior to anything that happened, I think the 24th of February this year. So on the 29th of September, we've moved into 2021 now. On the 29th of September last year, the CRU published a program of works to increase the forecasted generation capacity available to address generation capacity needs over the following 4 to 5 years. Importantly, to provide stability and resilience to the Irish energy system. So there will be times over the next number of years when there won't be renewables on the system. We don't see that there will be sufficient other sources for the times. Again, it's a cliche when the sun doesn't shine and the wind isn't blowing, that we will need these thermal plants. So that security of supply program of work is being brought forward by ourselves, by EirGrid, and by the Department of Environment, Climate and Communications. Lots of actions there. So the delivery through the all-island capacity auctions of over 2,000 megawatts of enduring, flexible, gas-fired generation capacity by 2030. Not necessarily always a welcome message that we want to invest and see the need to invest in significant amounts of fossil fuel plants in order to have a secure transition, and in order to have a secure transition. Procurement of temporary emergency generation capacity to cover expected shortfalls in the nearer term. Extending potentially the operation on a temporary basis of older generators, which would be higher emitting, and other actions to enhance the responsiveness of existing demand side units in the single electricity market and develop additional demand side capacity. And again, one might ask, why would one procure additional thermal generators? Why would one extend the operation of higher emitting fossil fuel generators? those you might say are not coherent with a drive towards net zero carbon, not, you might argue, not consistent with the 70-80% renewables ambition for 2030. Again, I think the concept or the discussion point in this seminar today is security of supply during that transition. There is a desire and a need for confidence that when you woke up and flick the switch, that there will be electrons available to turn on the lights to keep industry, the wheels of industry whirring. So again, difficult choices to be made, but this was the work plan we put together in that period. Seems I've been 10 minutes already. I better hurry up. You'll all know that there was an invasion, Russia-Ukraine. Well, Russia invaded Ukraine. In advance of that, noteworthy that we saw higher gas prices in 2021. Storage was not refilled in the summer of 2021. So even before the invasion, we had issues with higher gas prices. I'll skip through this. We have even higher price concerns now. We also have supply concerns with regard to those fossil fuels, coal, oil, and gas. You can read the numbers for yourself there, the amount that came to Europe from Russia. Gas is key for electricity in Ireland, notwithstanding the fact that for security of supply reasons, we mandate that gas-fired plants must have oil backup of either 3 to 5 days. On that, I would note that Ireland's gas supplies come from both Corrib and the UK. The UK itself is a very secure in European terms, is very secure with regard to the supply of gas. It has indigenous, it has Norway, it has LNG, and significant amounts of LNG and interconnection. In response to Russia-Ukraine, the European Commission brought out a document called Repower EU, and it asked for urgent actions on prices. I won't dwell on this one because I'm way behind schedule. It also said, acknowledging that gas storage was not filled in 2021 prior to the invasion of Ukraine by Russia, noting in particular that Gazprom-owned storage in the EU was at historically low levels and unusually low levels in 2021, to bring a legislative proposal to say that gas storage must be filled by a certain target by the 1st of October of every year, and coordinated, potentially coordinated purchasing behaviors. However, for those who are interested in the renewable transition, the European Commission have said, and I won't read this whole page, but it does say on the bottom left, diversifying gas supplies from a strategic sense, not to be reliant on one source. But the other pieces you'll see there are about decarbonizing, because every kilowatt hour you make locally, renewably, you don't buy from Russia, plus it isn't emitting carbon. Behind schedule, so I'll move on. The Irish government proposed a series of actions in a national energy security framework. Again, I'm well behind schedule, I won't read them all, but the ones I think those who are interested in the transition will focus on is, for example, to leverage the rollout of smart meters. Demand side responsiveness is a key element to say, maybe I'll turn my tumble dryer, dishwasher, washing machine on at times of high renewables, and I won't turn them on at times of low renewables. Not using discretionary electricity, where there is discretionary electricity during peak times, tends to reduce the need for fossil fuels. There tends to be more fossil fuels at peak times. It's a predictable way to help to reduce fossil fuel consumption, to put it that way. A review of the government statement on the role of data centers, peak demand reduction in incentives. That's an important piece if you're interested in the transition. Faster grid connections for renewables, accelerate grid connections and storage, roll out renewable microgen, praise supports for biomethane. Very importantly, in the longer term for net zero, development of a hydrogen strategy, and really just to prioritize the security of supply. My summary, he said 4 minutes late. maintaining security of supply during the transition is essential. Notwithstanding that it is a transition to net zero, in order to do that, there is a significant need for new investment in dispatchable generation, which means broadly gas-fired generation is required in the near term to maintain that security of supply. However, significant increases in flexible demand response is required from all demand, large and small. But the good news for those who are interested in and concerned about the transition is generating more renewables and utilizing more of this renewable generation through flexible demand, storage, etc., will increase energy independence as well as reduce carbon emissions from our sector. And apologies to everyone, I have gone over time, but thank you.
Thanks very much, John. And there was a lot of very interesting stuff there. So we'll forgive you the couple of minutes over, but we will rush on to Andy and see what Professor Andrew Keane has to add to the conversation.
Thanks, Majella, for the introduction. Hopefully you can see my slides in the right mode there.
We can see and hear you well.
Lovely stuff. Thanks a million. I don't want to kill people with slides, and we've obviously had 3 excellent presentations already, but just to maybe pick up on some of the points I think that John usefully set up, and I just pulled some clippings and note there from late last year. So around the time, as John mentioned, CRU issued a note, and there was concerns about generation adequacy. And looking at these, I almost think it's almost quaint given how things have deteriorated since then in terms of the invasion of Ukraine and the kind of, what Russia is now doing with gas supplies around Europe, having cut them off to Poland and Bulgaria. So where we certainly did have to take action to, bolster our generation adequacy on the system, on the grid, there's now that other real and apparent threat in terms of volatility of gas prices, which is extreme, and also potential threats to the security of gas supplies, albeit, as John says quite rightly, the UK is in a relatively strong position. But this just shows, I think, how quickly the situation is moving. The national context in terms of where we're at with emissions, and John kind of summarized this quite nicely in terms of where we're at with 2020 and indeed towards 2030 in terms of electricity. But in 2019, just to point out that 87% of all energy used in Ireland was from fossil fuels. So electricity is the shining example of us hitting our targets for 2020. Heat and transport, the other 2 sectors, not so much, let's say, albeit action has now been put in place. And obviously with fossil fuels go greenhouse gas emissions, and that's what's kind of summarized on the right-hand side. So there's a significant deal of progress that needs to be made. John's absolutely right, I think, to flag the 2020 achievement of the 40%. And like others, having worked in this area, obviously in academia, when we first thought about 40% for 2020, it seemed like a very ambitious, and it was, and far off goal. Almost immediately having hit it, the bar has to be increased. It was 70%, now it's up to 80%. And I think that is kind of how it is across all sectors in terms of the energy transition. The bar keeps rising, the acceleration keeps needing to happen. There is now that added imperative, I think, for our energy security in terms of decoupling ourselves, certainly as Europe from Russian gas. I did then want to point out, I guess, a European Commission communication, which was published in July 2020, called Powering a Climate Neutral Economy. And we had the pleasure of welcoming Professor Ronnie Bellmans from KU Leuven here in UCD yesterday, who gave an excellent seminar for those of us lucky to attend it. And one of the things he presented was noting this document and the 3 principles that basically it outlines. So first off is efficiency. Make a more circular energy system with energy efficiency at its core, absolutely. Second of all, that direct electrification of end use sectors is the way forward. And then third, and this is a priority list now, where electrification is difficult, then we need to promote clean fuels, which may include renewable hydrogen, biofuels, and biogas. And I thought Ronnie had a great line. We talked about this is basically a translation of the laws of thermodynamics into energy policy. And that's kind of exactly what it is, conservation of energy, energy exergy, everything that as engineers we learned in college, in UCD and elsewhere. And that is what we need actually to underpin our energy policy. So energy efficiency, so the kilowatt hour not consumed is the best one. But then clearly electrification is the path, and that's reflected in Climate Action Plan in Ireland. It's reflected in what's happening across Europe. in terms of the electrification of heat and transport. And while of course there's challenges with that, and as John very neatly points out, that may mean thermal plants and will explicitly mean that we still have thermal plants by 2030. There is still a path, a very credible path in terms of available mature technologies to decarbonize our electricity. There are, of course, the hard to abate sectors where, you know, you're not going to decarbonize aviation through electric planes for long haul aviation and so on. And that and other sectors like that is then where other let's say options need to come into play. I was going to skip to this slide then in that regard, which is taken from Michael Liebrich, who's a noted kind of commentator in this space around Europe, and it talks about, summarizes, I think quite neatly, the situation with hydrogen. And as people I think will be aware, there's a lot of excitement, a lot of focus on hydrogen as an emerging new, well, it's not new, but you know, potentially new large-scale industrial application and part of the solution. And this kind of highlights, I think, you know, a bit like an energy efficiency chart that you see in your appliances, you know, where the use cases for hydrogen might lie. And I think if you look at E, F, and G, and I would agree with this, it's kind of showing that electrification covers a lot of the immediate actions that we need to do. As you go up to A and B, you can see, well, this is really where we will need hydrogen in these hard to abate sectors. So the steel industry, shipping, long haul aviation, transcontinental trains. And what's emerging, and what it's really interesting to see emerge as at least an observer in the space, is the acceleration of the technology. And as battery technology and as electric drivetrains increase and develop quite fast, and obviously green hydrogen and a massive amount of investments going into that, it's the D and the C, let's say, rows on this chart where the interesting interplay and the competition will be to see, well, which is actually going to be the technology that, or the energy vector that plays out. But there's very little doubt in my mind that really electricity is where the future is going. The internal combustion engine is on the way out. It's just a matter of how fast and how exactly that comes about. Just to turn from that into the energy security question, and again, John gave a very nice description of this. I won't rehash it too much, but like, needless to say, we remain exposed to gas price volatility, massive volatility in recent days, with the actions, as I say, to cut the gas supplies to Poland and Bulgaria. As John has said, we will absolutely see increased use of money point and other thermal plant for the time being. My hope here is that this is a small kind of bump or an uptick on the road to a fully decarbonized electricity system, and I think it will be that. In terms of the electricity system, I'm absolutely right. The wind doesn't always blow and the sun doesn't always shine. And I was looking today, I think 2% wind on the Irish system and 4% on the UK system, albeit they've more solar than us. So very low levels of wind today, which is just what happens. So we do need those thermal plants, but really long duration energy storage is a key, almost unfound or unmature technology option that we haven't really quite got to yet, but it is one of the essential elements of the future grid. And what form that might take remains to be seen. I mean, it's not lithium ion batteries, just to be very clear about that. They just won't have the energy capacity to sustain a grid or a country for the required time. So that's a key feature, I think, of the future grid, looking forward to the future. Increased flexibility, as John has mentioned, and Claire gave a very nice perspective on this from ESP Networks. And a lot of the, as I say, the action almost is happening at that residential level, where we need to access the kilowatts and the kilowatt hours almost at the residential level. Smart meters may provide some help to that, but also I think the market and the market structures and the role of aggregators and the electricity suppliers within this is going to be very important. But that flexibility on the other side of the supply demand equation is very important. And then grid development, interconnection, we've heard from Jonathan very clearly, we need a green link, we probably need a couple more, and also a transformation. So Eddie O'Connor has talked about the supergrid for many years, and I think the time of the supergrid may indeed be coming about, where we really develop, and at a European level, if you look at how the grids are operated, there's an organization of grid operators, but there's still, I think, slightly a national kind of sovereign border perspective. That just needs to almost be washed away. And again, the physics of the system, of course, you know, the flow of the electricity has no particular regard for sovereign borders and that massive interconnection. And Ireland, of course, with its significant offshore wind resource, has a potentially significant role to play within that. just to mention on the markets, and I think it can often be overlooked, that the market we have, the all-island market, the electricity markets across Europe, are going to change and are going to have to change radically. And I think this slide is just trying to highlight that they already are changing quite a bit. 21% increase in intraday trading in Europe 2019 to 2020. There's an increasing move towards real-time trading happening on the electricity market. So the days of a day ahead where you line up your thermal fossil fuel plants and everything goes as planned. There's going to be errors in wind forecasts. There's going to be errors in solar power forecasts. There's increased stochasticity or uncertainty on the system. That's only going to increase. And that's why we need these real-time trading and market mechanisms to resolve these imbalances close to real time. And again, the demand side flexibility has a big piece to play in that. So just to summarize, system flexibility is really vital in this regard. The integration of our energy system, so the interplay between electricity and gas, we're going to be thinking probably a lot about this, I suspect, in the coming months as we consider impacts of gas price volatility and potential gas supply disruption come to bear. And water, I think, often gets overlooked as a resource, and it's important to be remembered that there is an interaction, significant interaction on the demand side in terms of wastewater treatment from water as a big energy user, but also water supply for the country and beyond that, particularly as climate change develops, needs to be kept in mind. And my final point is, remember the laws of thermodynamics, because they really do underpin how things will ultimately wash out, and they can be ignored, and we can have people kind of ignore them and talk about other things, but they will come to bear whether people like it or not. So I'll leave it there and hand back to you, Majella. Thank you.
Thanks very much. And I might ask our panelists now to come back on screen. Look, we are, we've had 4 really good talks there, and I've got a whole load of questions on the screen over here. So I'm going to propose I'm probably going to let this go 5 or 10 minutes over, but I'm going to ask for really concise, snappy answers if possible. Okay. So first question, which is probably for Claire or John, because both of you mentioned the smart meter rollout. Can you give us just a little bit more of an explanation as to how smart metering is going to help us with energy security? Whichever one of you wants to jump in first.
I was going to say something, John. There, yeah.
That's fine. No, I'll do my best with that one. If you read the Repower EU document, it's right when it says that what we can take away from peak times, we're taking away a high proportion of fossil on average from peak times. So that is a thing that smart meters can help you do. So also if the instantaneous price of electricity is low when there's high renewables, if people get the benefit of using electricity at those times, they have a financial as well as a let's say moral is the wrong word, but a social incentive to use more renewables. It is recognized, it is visible, you can see it. So the idea that by knowing when is a good time to use electricity because of high renewables, when is a bad time to use electricity because of high fossil, having the ability to see that you have done that and get some kind of financial reward to that. If you read the Repower EU document, and I think they're right, they say everything you can move out of fossil into renewables, even if it's a percentage shift, is better for security of supply. Also, if the peak is smaller, it's easier to meet the peak with the same investment. If the peak shifts around, you have less investment. That's good for investment costs, but responding to shortages, which can happen with smart meters, a signal to say, whatever you do, don't use electricity if you can help it at all for the next 2 hours. That helps with security of supply as well. It means there is sufficient capacity to meet demand with sufficient reserve. Things are more stable when the load responds to signals. That's probably a long answer, Majella. All facilitated by smart meters.
Yeah, and I suppose, John, with a few 100,000 smart meters on the system already now at domestic level, is there any sort of communications campaign planned, or are we going to rely on the supply companies to help educate people as to
so
to do things.
Yeah, so government launched a communications campaign today, some of which will target the Claire's $750,000. Is that by the end of the year?
No, we've got over 700. I think it's 770 now.
Yeah.
Moment.
So the $750,000 out of the 2 million meters broadly to use it. Also, we have mandated that suppliers must engage with their customers who have smart meters to explain to them how to do it. We created a primer where we ran lab sessions with ESRI to see what communication methods worked best, what got the best understanding into consumers. So there's a sophisticated, I like to think, approach towards promoting the use of those smart meters.
Excellent, thank you. I might move on to a question for Jonathan. So we've seen increasing volatility in electricity prices over the past few years during times of high or low wind, cold spells, etc. Even though more interconnection is obviously needed, won't significant increase in interconnector risk worsen this? Do you think there should be market reform across Europe to address this?
Yeah, well, I guess as Andy maybe touched on there is market reform ongoing in most European countries at the moment, moving towards a more real-time market operation. I think increased interconnection has sort of been proven to reduce prices where in most cases, I think maybe the volatility that we're seeing at the moment is more driven by gas and by other functions, and the increase in renewables the increase in interconnection will allow you to be able to transfer that low cost excess energy from where it's being generated to the areas of higher prices. So I think the answer to both is no and yes, and that the market definitely, the day ahead and the way the market runs at the moment in Ireland is maybe not taking advantage of all of that. John's got his hand up there.
Yeah,
and John, to preface, is definitely way more informed to answer the question than me.
All right, okay, thanks, Jonathan. No, I was going to say that volatility, an unpopular message, but price volatility is not necessarily a bad thing. In fact, it's probably a good thing for the transition. It is a signal to move away from consumption when prices are higher. It is a signal to interconnect different jurisdictions, which Jonathan will like me saying, but it is, if demand needs to shift and move, price volatility and responding to those prices higher when there's less renewables, lower when there's more renewables, that's part of it. People mightn't like it if they think about it, but that's the signal. That's a relatively good signal for high and low renewables, and it's a good signal to shift demand. So volatility within day isn't necessarily a bad thing. Volatility over time, I think, is probably a reflection of underlying events like shortages, structural shortages, or high price fossil fuel.
Thanks very much, guys. Sorry, my phone just decided to make a noise there beside me, so I put it on silent. The next question I have, well, I'm going to try and roll a few together. Okay, so there's a few questions around when will we see the end of fossil fuels, and will we always have fossil fuels? And I think though, John, I think that these questions, some of these came in before you had talked about that kind of end of things. But so maybe it's more in the area of, will we be able to transition thermal to the clean fuels that Andy talked about, and what any new plants that are being built, is that going to be a factor in it? So
yeah, so
I don't know.
Yeah, I would probably defer to Professor Keane for the longer term view on this, because I think some of what I'm going to say Andrew now said was indicative of, I think there's some uncertainty as to hydrogen. It's not at industrial scale yet. I don't mean uncertainty in that it is likely to be the storage of choice, the fuel of choice that allows us to decarbonize the last bit. So I focus on 2030 because I retire sometime in the 2030s and the actuarial tables say I die sometime in the 2050s. So you'll forgive me. But I think hydrogen, having been proven in an industrial, an industrial scale, is needed to say with confidence when we can say goodbye to the last of the fossil fuels for electricity. There may well be fossil fuels for other entities, and the thing to remember is net zero. It's not necessarily zero or zero emissions. It's net zero for the economy. I would suspect, at the risk of saying who might answer this question, Andrew, might I have a go at suggesting if you give a view on that?
Yeah, thanks, John. Yeah, you're good. That was as good as I could offer, probably. Yeah, like it is uncertain. I think the point I guess I'm trying to make is electrification can do an awful lot, and it seems to be developing quite quickly. But there's no doubt that there are sectors that it just will not be electrified, and that's really where hydrogen comes to pass. And really important sectors like aviation, shipping, heavy industry. And then the question, of course, is how do you make your hydrogen? Hopefully it's from renewable energy. But that's again where sorry to keep banging on about it, but the energy efficiency or these thermodynamics come into play. If you convert from electricity at a wind turbine into hydrogen and then convert that back to electricity, for example, I mean, the efficiency of that is bad, like 30%, I think is probably the best you're going to get, from what I understand. So you really need to be using the hydrogen in sectors where what they actually need is hydrogen, or maybe it's ammonia or something else that's developed from hydrogen, if you know what I mean. So there's a lot of kind of, I would say almost, infeasible notions going around, but at the same time, there's a risk you could throw out the baby with the bathwater and scrap hydrogen and think, oh, it's not going to work. But no, we absolutely are going to need it. And that's, as you say, John, that's when we can get to net zero. And net is an important word to note as well.
Okay, I've another question, which is probably for Claire, but if it's not, maybe somebody else will take it on. It says, how large a role will domestic solar PV play in decarbonising the electricity system? Today was a great day for solar if we had it. And I suppose, how will we cope with the likes of domestic PV being there on the distribution system at that low end?
Yeah, so I suppose in the latest climate action 2021 is indicating that I think it's up to 2.5 gigawatts of solar PV. Just solar PV is by 2030 is the target. And I suppose we're installing, so there's an increase in microgeneration, and certainly there's also a number of pilots happening on mini generation at the moment that are happening. So certainly there's a view, there's a role for solar PV. And I suppose, as I was articulating there, the key thing is, having that renewable close to the load center, and in ensuring that communities can actually be self-sufficient for a portion of the time is definitely has a part to play. And in order to ensure that the network can actually facilitate that, that comes back to be it flexible demand, but also being able to ensure that the voltage limits on the network are maintained so that we can actually control that generation when it's really, really sunny and there's low demand at a local level as well. But certainly it has a role to play. But I suppose in the immediate term, like when you're talking about at a macro level, it's around, at a local level, I think it'll be more effective rather than at that kind of overall system, from an overall system perspective. But I'm sure John will have a view as well.
And I think Jonathan wants to come in on that one as well.
Yeah, just to say, I think like solar in general in Ireland is maybe a little bit behind the curve compared to our nearest neighbours. And if you look at the UK, and on a sunny day, you could have up to 25% of their energy coming from PV. So that's, and that is a big impact on a sunny, low wind day. And I think I would be really happy to see a lot more PV come online, be it large scale in a field somewhere near a transmission node or on rooftops. I think would be. obviously within all the limits that Claire has mentioned, and there are obviously operational challenges with all of this, but it's definitely something that we need to look into more.
If you want me to come in, I can briefly, Magella.
Yep, absolutely.
Think it's probably fair to say, it is fair to say Ireland is behind the curve when it comes to solar. Really a function of the fact that there was a refit scheme for wind, but there wasn't a refit scheme for solar. Solar can have good negative correlation with wind. So on a large scale, one can use to a significant extent the same wires for wind and solar without them necessarily always competing with each other at the same time. And then the microgen, the micro scale solar piece really transforms, it would appear, the views of people with regard to the transition. And at least that is the hope, and I think a reasonable hope and expectation that you get a panel on your roof, you may get an EV. You probably have to have money to do all of these things, but then you may be invested in doing other things that might also help the transition. It's not out there, it's not outside my home, it's actually on my roof, and it becomes in my life. So that kind of small scale piece could be really important for the flexibility we need, for the acceptance of the horrible infrastructure, the wires that people don't want. They want renewables. They maybe don't want wind turbines. And even I read some press clippings, people don't want solar farms either. But to get that public acceptance there, the microgen piece is important. That happens broadly to be PV, but PV has system-wide benefits as well. Thanks.
Okay, I see. As the discussions have been going on, the questions have been piling in. Okay, I'm going to give a couple over to Jonathan now. So one is about years ago, DC Links didn't give us system synchronous support, and clearly, if we're going to have Greenlink and the other DC links that are either existing or coming down the line, is that still the case? I suppose is the question. Can they provide that support that we've traditionally gotten from our big generators? And I suppose the other question is the question about nuclear and the fact that quite a lot of what you might import from the UK is nuclear. Should we be going nuclear here?
Two broadly very, very different questions. So I'll take the first one first. So on the yes, so it's a really good question. Traditionally, old HVDCs didn't have technical capability to help with the network. They were really a plug-in, and they were more like a load than something that actively contributes to the network. The new technology of HVDC, which is what the second one that was built maybe 10 years ago between Ireland and the UK, the East-West, and our Greenlink and the ones upcoming are a new version of that technology, and they use I guess control to mimic that function that the old synchronous generators would provide. It's not the same, but it can provide the same benefit in a different way. The second one on nuclear, I mean, the interconnectors will import what electricity is to be imported. They're only electrons. The electrons are neither green nor blue nor gray. But I think that the nuclear question is a really good one, and I think it's something that personally I think that we maybe should be at least opening the discussion on it in Ireland. It seems like there's a closed discussion, and maybe it's a bit taboo to even mention it. But I think definitely we should be open to the discussion.
Thank you. And I think I might just go to Andrew as well on that issue of system support. And I think you've done a bit of work, if I remember correctly, in that area of trying to enable maybe some of our renewable generation to mimic some of the characteristics of thermal plant.
Yeah, no, that's right. Yeah, no, like the system services and EirGrid have also done a lot of work on this and defining it and working with ESB Networks, of course, on trying to, I guess, access those services from distribution connected resources. Yeah, like the traditional synchronous generator, as Jonathan says, power electronics can do an awful lot that can kind of emulate or replicate similar type things, but you can't quite replicate the real inertia as you get from a rotating mass or the synchronous torque within electric fields of the synchronous machine. I won't go too deep on this. So you can go so far with it, but you can't quite get the full way. But increasingly, if we're talking about 80% renewables and we're operating the grid now in real time up to 65, I could be wrong.
75.
Maybe, sorry?
75.
75. Thank you, John. I mean, all that wind is non-synchronous as well. So that SNSP, for those in the know, system non-synchronous penetration, I think it is. Yep. I'm sure there's people in from AirGrid listening in going, yeah, that's right, Andy. We're pushing that the whole time. And maybe just to remember that as an island, we're really leading the way internationally in terms of the level of, system non-synchronous resources that we're achieving. So again, it's a good news story in terms of Ireland leading the way. So I think you wanted snappy answers, so I'll stop there.
Yeah. And Jonathan, you want to just come in there?
Come in and agree with Andy there. And in terms of like having that rotating mass, like ESB, it should be pointed out of just today brought delivery of a synchronous condenser and flywheel to the Moneypoint site. And that's another example of using the technology that's providing that sort of rotating mass inertia, and it's another really good and a really good, I guess, snapshot of how we are leading the industry in that particular part.
Look, folks, I have loads and loads more questions here, but we're coming up on 1/4 the hour. Okay, so what I'm actually going to do, we're going to take those questions away, and we're going to look at whether Mark 2 of this this discussion, which we'll be aiming for in the autumn, will try to go into a lot of those things in more detail. I'm really sorry for everyone who has put in a great question that we haven't gotten to it today, but we will absolutely continue this conversation. It just falls to me now to say a really big thank you to all our speakers, to our audience as well. I see that a very large number of you have stuck with us right to the end. We will be making this recording available on the EGA website. I just want to say thank you, everybody, and I hope you get to enjoy what's left of a nice spring sunny evening. So thank you all very, very much.